of this then don't volunteer, but I would like 5 volunteers that correspond to the sample units. So I need 5 people to come up front. Oh, there's 1. Any other volunteers? Okay, 2.
Okay.
3, 4, 5. Okay, we got it. And each of you is identified by a particular hat. And, well, that one has something biological on the top. That one is just the party person. So
This is a bit, I'm thinking of a head to Perfect.
Each one of these corresponds to one of the sample units on the screen. And so I've got this data actually put into the computer. We ran it in the computer. We'll do it in lab or in a lecture here. What I did then is take this little made-up data set where we've got sample units and species, and then calculate a Sorensen distance matrix from that. And what I've done is make ropes that are the same length as these distances. That is, they're all proportional to that. So what we're going to do is, well, you guys know that nonmetric scaling, we start with the distance matrix, and then we're going to create the ordination somehow from that using an iterative process of gradual improvement. We're going to start with a totally crummy relationship. And by the way, you're just standing here at random. Could we claim that as random-ish?
Close enough.
Okay, so that's our random configuration. We've done that part already. And then each one of these is labeled with a pair of sample units. So each person has to hold on to all the ends that show their distance to everybody else. So where's a 1 and a 3? There's a 3. You can start unwrap that one. What do you got there? Well, I can't see your number. You're a 1. Okay. 2 and 5. 2. There's another 2. You're the 4.
Sure is.
This is going to be hard to now don't you move. You have to move back.
Well, I had to.
We have to,
I
no,
couldn't move because.
no, you have to stay where you are.
Should I grab
This
it?
is a random initial. As soon as you start moving, you're going non-random on me.
Yeah. You would hold multiple
Are you
ones, right?
ready? Yeah, I'm ready.
Here's a 2. Well, we got lots more distances to hand out here. 3 and 5. And 3 and 4.
3. Oh.
And 1 and 4. Okay. And 1 and 2. This
Goes
is.
to 5.
Oh, you guys are right next to each other. There's one more.
It's random.
It is random, so some of them are going to be pretty good to begin with, aren't they? Yeah.
Okay. Want to take number?
Yes, there we are.
So,
Wait, there's
I
a
have an
plus N here.
I need a 3. Angie. Where's,
wow, you have a bundle of rope. Now,
You're
if
an
this was
outlier, I can see it.
if this was a decent ordination, according to nonmetric scaling criterion, there would be low stress, which means the rank of distances on the ropes would be the same as the rank distances in the room space. This is our ordination space. We're doing a 2-dimensional ordination, unless you guys want to go up and down the tables and stuff. That would be a 3-dimensional, right? So we're going to come up with a 2-dimensional solution for this that attempts to improve the stress. So you can see, like this, but that's stressful. That really having a hard time with that big ball of string there. So what we're going to do is try to improve the representation with taking little steps. We'll just use a single step. So you guys think about what direction you're going to move relative to the other people. Don't move yet, but what direction you're going to move to relieve some of the stress.
like further?
So that means you don't want this, that's stressful, and a big wad of rope in your hands is stressful too. So you want to take a step to relieve that. And actually some of them look fairly non-stressful, I'd say.
So is this non-stressful or is this one non-stressful?
Well, these are pretty good, like your distances are sort of proportional.
Right.
Looks like you got a little bit of slop here,
So like that.
Yeah.
and
No, I
these
know,
guys
it
have a
is
pretty
all-
fair amount of slop right there. So,
So is the slop stress?
yeah, slop,
Okay.
either one is just like it's too much tension on those ropes, like you're bleeding way out. And actually, this is sort of cheating. I hate
Well,
to
I'm
say
just
that.
holding her hand for it. I'm holding her. There you go.
I mean, because you're really a point. Not 2 points. You see what I mean? Okay, there we go.
My bad.
So, now, does everybody know which way they're gonna move?
Yeah.
Yeah.
Okay, so take one step.
go at the hall.
One step.
Be like a
Oh,
big
now
step.
you took a big step. That's okay. Now, the way the nonmetric scaling works is the more stressful the situation for you, the bigger the step you'll take.
Oh.
So
I'm
you,
way
no, you
out
don't,
there.
no,
That's really.
there's a limit on the step size.
Can I
So
start where I
you can
started?
only take a certain size, up to a certain size. So, okay, we're,
You should let her do every step. Okay. I was here.
Oh my gosh. She's going out in the hall, I can see it now. So that's actually an improvement. And we only done one step, right? Let's take one more step. And if you're pretty good, you just take a small step. You don't have to take a big one, but you have to take a step. You cannot just stand still.
So all the points have to move.
All the points have to, even if you can move just a tiny bit, just like this, if you're pretty good. But you have to move. Okay, and one more.
This
Okay, so, and then we can keep going, but now we would recalculate the stress and say, did we actually improve it? Because we may have actually made it worse.
Some parts.
Except for the.
Yeah.
Yeah, you're doing pretty good. So let's take one more step. So I'm not sure we actually improved it yet, so that's what we're looking for. The computer would take a bunch of steps, and basically when you successfully have no improvement over, let's say 10 steps, then you quit. So now let's look at the configuration there, and here's one run on the computer and how the points move. So here's point 1. Where's point 1? Right there. Point 1 stayed in one place for a while, but then sort of took a hike across here and ended up there. Of course, there was a different random configuration to start with. So each of the points moves in its own pattern to reduce stress. Here's what happened with the stress in the computer. It actually went down quite rapidly and then went up to a little peak there. Fortunately, we didn't end up there, and it continued down and found a better solution. So that would be kind of like it started to go one direction, it was getting worse, and that point then got pulled back to a less stressful solution. And then let's see what the final solution looks like and how it compares to what we got here. So here's the starting configuration, which was different than what you guys started with, and the final configuration. So the computer put 1 and 2 basically on top of each other. You guys are pretty close there. And then 4 and 5, well, 4 is kind of between 1 and 2 and 3.
Angie and I had switched.
4 is between 1 and 2 and 3. Yeah, that actually matches. So here's point 4. And then 5 is off to the side. Got it. And 3 is out in the hall. Okay. So, thank you guys. Congratulations. I think you were a good nonmetric scaling team. Are there other questions on this?
So is like stress relative to, I mean, each like iteration is independent of the previous one? Like if it improves, I guess I'm a little confused on.
It's not going to be completely independent because you have basically the same configuration, right? You make a tiny adjustment. So the stress in one step is going to be very similar to the stress in the previous step. You're hoping for it to decline to some flat place where it's no further improvements are there and you're just stabilized. Now, oh.
Sorry, so when you, like, because when you give results of an NMS, you give the stress level, and you're saying that's the stress at which the stress level cannot be bettered by further moving the point, so that's the acceptable stress level for that specific
Right,
ordination
so
space.
you will, what you'll do, because you have this random starting configuration, is you'll run it many times, and you'll take the solution that has the lowest stress.
Okay.
For a given dimensionality.
Okay. I had a follow-up question, and I don't remember what it is.
Okay, well, if it comes to you, let me know.
It'll come.
So I want to point out one difference between what we did in non-metric scaling. When we're visually evaluating the stress, or when our team was, they're really applying kind of a metric instead of non-metric, because it's very difficult mentally to think about ranks, right? But the non-metric is based on the ranks. So this was actually metric multidimensional scaling, because you were thinking about distances in the ordination space and the actual lengths of the ropes, not the ranks of the lengths of the ropes. That's what it would be if it's true non-metric. All you would be worrying about is the ranked rope lengths. And trying to get the configuration of you guys, the ranked distances between you, to match the ranked distances between the ropes.
So if we're trying to figure out that cap of iterations where you no longer improve, but kind of just minimal improvement, are we looking at the minimum stress value in the original or in the original section and then in the randomized section? What are we
No,
evaluating?
okay, she said that we're looking at random versus real. No, you can do it completely without reference to a randomized data set. So basically, you start with an initial configuration, you try to improve it as far as you can, save that result. There's your best one for that, then do it again. And if you beat the one that you saved previously, jettison the old one. And keep doing that a bunch of times and saving the best result.